Hello everyone. Um, Welcome to ACSF 4230 and ACSF 5230, Mathematics of Compound Interest. So this is module one. We are going to learn about interest rate. So in this class, you will learn many topics related to financial mathematics. We are going to summarize these topics into following categories. We are going to learn about interest rate and time value of money, annuities, comprising, yield measures, spot rate and forward rates, rate of return, price volatility and bonds, immunization. This class is online um, and also it's an empty engaged course. So please go and read the syllabus very carefully. As part of this course, you need to complete empty engaged signature assignment. So module one is about interest rate and time value of money. So we are going to learn about interest rate, then discount rate, and then cost of interest. So we are going to see how these topics going to be connected to each other. So we are going to we are going to learn about the formulas and then connect each of these terms to one another. So the first, money and time value. So the notion that money has a time value is one of most basic concepts in financial analysis. Now, money has a time value because of the opportunities for investing money at some interest rate. So money has a time value. This idea, everyone know about that. For example, if you have $100, you can do many things. Maybe you can go to a restaurant. Maybe you can buy a book. Maybe invest, save in a saving account. So you have these opportunities. Also, you have time value. Okay, so you can either use it today, maybe you can buy a cloth, or you have opportunity to invest and then get return later and then use that return to do something else. So money has a time value. That's why when people lending, they would ask interest because they are giving away the opportunity to use that money today, so they want something extra when they get money back in the future. So this money and time value concept is really a basic concept in financial analysis. So in previous slide, we kind of like to talk about interest rate, but not really defined. So now we want to get into that specific term. So interest may be defined as the compensation that a borrower of capital pays to a lender of capital for its use. So somebody need to give their capital to another person to use. So the borrower need to compensate the lender for that for the use of that money. So the interest can be viewed as a form of rent that borrower pays to a lender to compensate for the loss of use of the capital by the lender while it loan to the borrower. So let's say you have $100 and then you give it to your friend. Now you are giving away the opportunity to use that $100 for you yourself. Okay, maybe you could have go to a restaurant and eat. You can buy clothes, or you can go to movie theater. So you are giving away that opportunity, and you are giving the money to your friend. So because of that, you are expecting something extra in return. That's the basic idea of this interest. So in this course, you will learn a lot of terminology. This is just the module one. When you go to annuities, you will learn really a lot of different symbols. So for this one, these are the basic terminology. Principal, which we use capital P, is the value of initial investment. So then we have accumulated value. There's no notation. You may see some A, capital A as accumulated value, but that's the idea is the value of the investment after period of time. Then you have interest, which is capital I, the difference between accumulated value and the initial investment. Then you have interest rate, the rate which you, which you which we use to calculate the interest. So this one is the difference. Okay, it's the difference between begin and end. So that's basically this item. But in here, this is a rate. So you need to observe that. This is a simple line, there's a capital line. This one is capital line, this one is simple. This one will be a percentage or decimal. Um, then we have future value. Sometime you will see accumulated value and future value, they are basically the same, but the concept may be different in bit. Future value is the value of investment at some future date due to the accrual of interest. So accumulated value is it's really accumulated. The future value is in a way that you are saying in future this would be the value. Okay, so you can see that there's a difference between those two terms. Then you have present value, the current value of the investment. And the term is the length of loan or investment. So these are the words you will hear when you are going through this module. So just keep an eye on these terms. So now we are going to discuss about accumulation and amount function. So here you can see two functions. One is accumulation, which we use simple AT. So AT, which is the accumulated value of one unit. It can be $1, €1, €1. So it's a accumulated value of one unit at time t. So this is accumulated value of one unit. And then the amount function gives the accumulated value of k unit. So the basically AT is k time the simple AT. This one is one unit. This one is k unit. That's it. So you can see the formula is for the So right away you may ask, okay, yes, you write, you wrote this AT, but what is the real how it's look like? Okay, so later you're going to learn about this and the form of AT under different mode. So simple interest, which would give you the AT to be 1 plus IT, and then you have compound interest, which would give you AT to be 1 plus alpha T, and so forth. So that's for the basic feature. But right now we are just using a function form. It can be something. It need to be defined actually. So then the question become, okay, so here we talk about the cumulative value, basically. Okay, then how do you calculate the interest for effective for given period? So the effective interest rate for IN, so basically that's the effective interest rate for N period. So you have this period. So for this period, IN, that's what you want to calculate. This is the effective interest for N period. This is the first period, first time period, and this is the end time period. So we want to calculate the interest rate for this particular time period. So what we do, what was the cumulative value at this point? That would be AN minus 1. Okay, so AT is the cumulative value at time t. And in here, this is the equivalent value at time n. So then the rate is going to be, of course, you can see that this is the begin, the end. So in order to get the rate, what you do, you take the end minus begin, divide by begin. No? So that idea is what you see in here. So your rate is going to be a n. Now, of course, you can substitute using this formula. You can substitute the accumulation function instead of amount function. It's amount function. When you do that, you can see that the k is going to cancel out. So basically, you take k time and k cancel out, and you will get this. So that's how you calculate effective interest rate. Regardless what kind of function we are using for amount function or potential function, you can always get effective interest rate for n time period within this. Okay, now we want to be more specific. So far we just used the accumulation function AT and amount function AT. Now we want to give some specific function form to this. So the first one is a linear function. AT equal 1 plus IT. AT equal. Now, right away, you can see this is, you can see y equal 1. Y equal mx plus c. You are, you graph this. So what is our x? X is time. This is our x. So this is time. This is AT. And time 0, when you time 0, AT is going to be 1. It's the equivalent value of 1 unit. So at time 0, you have 1 unit. So there is going to be the slope is going to be high. So this formula, if you use this formula, then the interest from that formula is called as simple interest. So then you can calculate the future value, basically present value time AT. Which is going to be future value equal present value time 1 plus IT. This is going to be 1 equal present value time. By the way, so now from here I can calculate the total interest. How do you calculate that? Basically, you take the future value and subtract the present value. From here, you can see that future value equal present value. You expand this present value time IT. We can bring it here. So future value equal present value time IT. So total interest. This is your total interest. Right? So that would be present value time. This point. Basically, this is future value. So here you can see a question which asks for simple interest, calculate the effective rate of interest for nth time period and graphic. Comment on the graph. So let's calculate IN from the previous slide. Here you can see the formula. It is AN minus 1 over AN minus 1. By the way, you know the formula for AN. AN AT is 1 plus IT. So AN is going to be 1 plus IN. Now, if I substitute that into this formula, it's going to be 1 plus IN minus 1 plus IN minus 1 plus Now I can expand this. So I get one again. You can multiply these two. Now again, plus 5. Please do it this by yourself. Do it yourself and then come and calculate the difference out. You get I over 1 plus I plus 1. Now, so the question is what kind of graph this is. Um, you can see that this is basically a decreasing graph. Why is that? For example, when n goes to infinity, you can see that the lower term, in the denominator, I time n minus 1 going to be increased. So the total value is going to be 0. You calculate the limit n goes to infinity, a n. This term goes to infinity, so that this entire thing is going to be 0. So you can see that effective interest rate as time passes is going to be almost 0. So here you can find a problem. It is asking 1 year later, so you have a deposit of 1,000 into saving account. 1 year later, the account has 1,050. What is the principal? So of course, the initial amount it is 1,000. What is the interest earned? So the future minus percent value is 1050 minus 1,000. It is going to be 50. And what is the annual interest rate? So it took 5 years. And it took 1 year, so you can calculate the annual interest rate. So basically, IN, you can say first year effective rate is 10.15 is I'm using AN minus AN AN minus 1. So here's another question. Suppose you get a loan of 1,000 and promise to pay 700 after 4 years. So what rate of simple interest does this correspond? So you can use right away simple interest rate model. You have future value equal present value time 1 plus IP. So the question says future value is 1,700, present value is 1,000, time is 4 years. So you can have substitute those values and calculate the I. 1,700. You can do the remaining simplification. So here you can see another question. Please try to, especially in this one, they're asking I5, effective rate for 50. You may want to calculate that using that formula. AN minus 1. So I will leave that for your side. So here I want to mention that when we are calculating interest, we need to know how many, like we need to know the time, how to calculate time. So there are different methods. Sometimes people use exact, that means actual over actual. Sometimes ordinary simple interest, basically 30 or 360 method, or the bank first rule, which is actual over 360. So depending on the method we use, the rate may be different. So you have to be careful which kind of rule they are using to calculate number of days. between the to get the time interval. I will leave this these two problems. We will come back to this later. I want to do this in calculator, so I will come back to this later. So now compound interest. So in here, earlier we learned about AT when it's looks like 1 plus AT. So this model we call as simple interest. So now we want to know what happened. This looks like 1 plus I to the power t. So this model we call as compound interest. So uh, Einstein called compound interest as the eighth wonder of the world. So basically, um, you can see that it's compounding. You will learn why it's compounding. You can see that over time, basically it's look like exponential. It's like a power function. So if you graph this is time. This is 18. At time 0, 1 plus I to 0 is 1. This looks like this. So instead of a straight line, linear function, it's like a power function. So basically, if you graph the simple integer model, it's going to look like this. This is 80 from 1%. This so when time is less than 1 year, your simple integer model is better. But if it is more than 1 year, this is going to be 1 year. And you can see the both are going to be same. Um, when you substitute one in the simple integer model and one in the components model, you always get 1 plus I. But then after that, after 1 year, uh, the compound rate model is going to have more accurate value than the simple integer model. So it's a better model. It's a better model for ones who are lending or ones who are saving. We don't know better for who. So here, again, you can see that we can come up with we can calculate the future value, present value. So this is the formula, basically the future value equal present value time AT. Basically, this is AT, amount function equal K time, right now, time accumulation function. So we use future value for this one present value, and then this module, this formula comes. Then from in here, we can substitute for AT, and then you get the formula. Okay, so now we want to calculate the effective rate of interest for nth time period. Now that is still same. Okay, so basically IN is going to be AN minus AN minus 1 over AN minus 1. So we substitute the formula. This is going to be 1 plus I to be N. Now this is going to be 1 plus I to be N minus 1 over 1 plus I to be N minus 1. Now 1 plus I to the N minus 1 is common factor, so you can take it out. And you can cancel out the numerator and denominator. So you will end up with 1 plus I. So the effective rate for nth time period is always constant. It's going to be constant. Now, if you go back to the simple interval model, it had something like this. I over 1 plus I minus 1. So basically, when time n goes to infinity, so this is In. So when n goes to infinity, In equal to 0. So saying that effective rate is really zero. But in this case, you can see IN equal I. So when n goes to infinity, IN is still I, so it is a constant. So which is desirable for ones who's lending or ones who are saving. That's something we need to check. So here the question asks, draft $1 under simple and compound rate model. We did that in actually here. You can do it again. But then you can comment on which one you prefer. Which one you prefer? It's depend on time. So if it's time less than 1 here, then a simple rate model. Time is more than 1, then compound. This time exactly equal 1, then you have rate model. You have both going to give you the same output, same feature. So the question asks, suppose you invest $1,000 and your investment grows according to a compound rate model of 3.7 for 4 years. Find the balance at the end of the 4th year. So I'll write the formula and then you can continue from there. The future value is present value term 1 plus y to the t. And the future value is what we want to find. Present value we know it's 1,000. 1 plus rate given as 3.7. Time is given as 1. So simplify this and you get the answer. So again, here you can see that in here, I just said like 4 years. So what if it's not like that? What if it's like time between 2 days? August 1, 2021 and 2015, 2022. Then we really need to know how to calculate that time interval. Basically, what's the method we are going to use? Is it actual over actual? Or is it actual over 360? Or it's 30 over 360? That's really important. So that's why this question is. We'll come back to this question. So here you can see that we want to discuss terminology used in market. In the market, you will not always see interest rate quoted in effective way, as effective interest rate. So the term of effective, so we will see two different kind of rates, effective and nominal. So we need to understand what's the difference. So the term effective is used for rates of interest in which interest is paid once per measurement period. So basically once per year, once per month, once per week. If the rate is given as, let's say, 2% per year, and per year effective, or we can say 3%. So this means like the rate calculated per year effective. So if you had $1 at the very beginning, then after 1 year you have, if you use the compound rate one, that's going to be 1 plus 0.02 to the power of 1. So you will get 1.02 at the end of the year, effective per year. If it says 3%, let's say per month, effective. So then it's going to be, let's use the same one. So then if you had $1 at the very beginning, then per month, your rate is 0.02. Then you have 12 of those. You have a marker. That would be the total you have at the end of the year. End of the month is 1 plus 0.0. End of the 12 month is 1 plus 0.0. So the word effective, you have to be careful. So how that's going to work. Is it monthly, is it yearly, or is it weekly, or is it daily? So you have read the question carefully to understand. Sometimes there may be situation where interest paid more than once per measurement period. Then it is customary to use nominal rate, quote. So basically a quote, a rate per measurement period. So we need to understand what that means. So that kind of rates, where rate quoted, Mm, That's that's called as nominal rate of interest. In many instances, interest payments are made for period less than a year. Example, daily, weekly, monthly, quarterly. When this happens, the period interest rate is listed as nominal annual rate. So how this going to work? So let's say you have 12 months. You have 12 of it. Mhm. So, so the um, so the nominal rate is going to be look like this. So you take the so the rates are now um, for month, but you want to get the you are quoting for year. So quote for year, but that's not effective rate. Okay, effective rate is actual per month. So let's say it's 2%. That's only for this 1 month. Then what you do, you multiply it by 12. It is going to be 24%. Then you would quote this as nominal rate is 24% compounded monthly per year. So then how do you get back the real rate? You divide it by 12. That's effective per month. This is effective, okay, per month. That's the key. So you are quoting for a year, which is not effective. What you do, you take the effective one and then you multiply um, how many units you need to per year. So in this case, you need 12 months to get to the year. So you multiply 2% by 12 and you get 24%, and you say its nominal rate is 24% compounded monthly per year. Um, so here you can see the wording. Nominal annual interest rate is the rate of IM, convertible or compounded or payable M times per year. So M is how many times you have. So how do you get the nominal rate? You have rate divided by period. So in this case, if you look at this, um, in this case, if I say 24% divided by 12, I mean, you have this both there. Okay, so in this case, I actually get that 24% divided by 12 and then time 12. That would be the 12%. So this would hold also as an APR. When you get a credit card, you will see this annual percentage rate. APR is basically nominal rate. It's not the effective rate. So if you know the annual rate, the nominal rate, then you can get the effective rate using this formula. So let's say you are quoting for the nominal rate is for actually quarter. So, so then this is nominal rate payable 4 times per year. So usually the notation is then I4 because it's 4, then you use the I4. So I4 is actually you take this effective rate per quarter. This is one, this is the second quarter, this is the third quarter. So let's say same rate. So so what you do, you take this effective rate for this quarter. How do you get that? You divide I4 by 4. This one give the effective rate for 4. So now this is effective. This one is effective. For what? Not for year. Effective for that quarter. Okay, so what? Then what you do, you you have you want to get the effective rate for entire year. So what's going to happen? So if we had $1 here, then it would be grow into 1 plus I 4 over 4 to the by end of the first term. It's going to be developed to 1 plus square by the end of second term. So it goes like this, and at the end of the fourth quarter, it would be look like this: 1 plus I 4 4 to the power 4. Now, if you had effective rate, like if you had $1 here, then it should be also give the same value: 1 plus I to the 1, because this is per year. So then this should be same. So 1 plus I should be equal to 1 plus I 4 over 4 to the power 4. So that's the relationship. That's what you see in here. So this is also called as APR. So that's what you see in the second. Now you can see annual percent. This one called as APY. If you want just APY, you can mark the other side, and you will get this second equation. So here question asks, suppose you are earning 2% at the interest compounded monthly. What is your annual nominal rate? What is your annual effective rate? So this is 2% interest. This is effective. Per month. So that means basically this time now. January effective rate is 2%. So February is 2%. Think the way up to December is 2%. So if you had $1 here, it would be towards the 1.0. Then it would be going to 1.02 square. So by here, it's 1.02 to the square. Now, how did I get that? So I know that effective rate per month is 2%. So now the question asks annual nominal rate. What's the notation? So the annual nominal rate that's going to be I12 divided by I12. What is that in 2%? 2% is actually I12 divided by 12. That's what it is. So, so if I use that formula, then I can get the annual effective rate. But before that, what is your annual nominal rate? So per month effective 2%, then for year, remember the method, we'll multiply it by just 12. It's going to be 24%. So your I12, the nominal rate is 24%. This is nominal. But then you have 2% is effective rate per month. Just remember, this is effective. When you use effective, you need to carefully consider for how long, effective per month. The question asks effective per year, because that's a difference. Then the 24% is actually nominal, it's not effective. So just be careful with these rates. Then what is your annual effective rate? You take 1 plus. This is give it effective rate. This is I12 divided by 12 is 2%. If you want I12 as 24%, you can do that. You can just add that 2%. That give you 2%. So that's how you can do it. Interest is compounded semi-annually and resulting effective interest rate of 12%. Find the nominal interest rate. So compounded semi-annually and result in an effective rate of 12%. Find the nominal rate. So you can see that it's compound semi-annually. For 6 months. And the effective rate was 12%. So for the entire year, now they are giving the rate is 12. And we won't find the nominal rate. So the first we want to find the we can use the equation right away. Sure. I can write the one first. I equal what's the rate we are looking? I2 is basically nominal rate compounded twice per year. Two times per year. Now I can, so the question is really asking about I2. So we can substitute value 1 plus I is given as 12%. I can take the square root of both sides. So to subtract 1 divided by 2. That would be that. So here is another question. I would leave it for you to do. Just try that out. So this slide, I would like to give you real life example, part title alone. You have to be part of this course. You have to be really um, educated about what kind of rates they are offering. You need to use this what you learn here. If you go to part title alone, you will find the rates sometime over 400%, 1000%, and rates like that. Please read these things. Go to these links and read what's in there. You will find amazing facts. Okay, so next section will be discount rate. I'm going to stop right here and then we'll meet again.